Hey everyone, this is David de Hilster, and welcome wherever you are in the world. Good morning, good afternoon, good evening. You have reached the Saturday Science Chats. Hey, it's David de Hilster. Oh, look at all these things popping up. Yes, I haven't been here for a while, but unfortunately, my dad was in the hospital for almost a month. He's having some trouble, heart troubles and stuff. And of course, those things take priority, but really happy to be back. He is at home, um, doing okay. Um, it's a new normal for us, but it's going to continue. We got a great experiment actually that has to do with current and magnetism. That's really pretty revolutionary, and it's pretty simple to do. Anybody can do it. So we're going to be getting back to our science. But I want to welcome everybody today. I'm sure lots of people are staying away because they know, hey, I'm not an etherist, but it's going to be a fun day because I've been thinking about this for a very long time. So what are we talking about today is modern ether theory dead? Is there a possible fatal flaw? And I've been thinking about that for many, many years. And I've been thinking about arguments I hear from etherists as well and all the objections. But this is really an exercise in, logic and trying to figure something out. I'm not here. There's no vendetta here. It's I say this constantly, but my father and I have a different model that's not ether, and that's not why I'm trying to kill ether. I'm trying to figure out why I don't like it. What is it about it? Is there something there that I could finally say to myself, I don't believe it's a good model. I already do. I don't believe it's a good model, but it doesn't mean I'm right about that. But is there something over these decades since I've not been an etherist, I've known about ether for a long time, that could be possibly fatal for me? And so that's what we're going to talk about today. Ether could be right. Absolutely could be. But anyways, I want to congratulate you all for watching. And I do want you to think about subscribing. We have 995 subscribers to our YouTube channel for the John Chappell Natural Philosophy Society YouTube channel, the CMPS YouTube channel. So please, 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 if you can just take a second. It's real easy. If you're on your phone, just put your finger there. If you're on a computer, just put your mouse. Subscribe to the John Chappell Natural Philosophy Society's YouTube channel and get us over 1,000. Well, when we get over 1,000, we can start taking donations directly on that. Of course, I do want to thank my Dissident Science YouTube subscribers. It keeps going up. I mean, it's actually picking up quite a bit. We're almost up to 4,200 subscribers, and I want to thank all of them and all of you for watching. And I know a lot of people do watch this recorded. In fact, I got a lot of messages because this is a hot topic, I know, because so many people in the world are etherists who are outside the mainstream. And so if you are watching recording as well, remember to hit that like button. It really helps us too, because every time you do, the algorithms out there that calculate who should be watching what that certainly helps us. So please like and subscribe, and congratulations to you for even sitting here and trying to become a critical thinker. And as Aristotle or whoever says this, it is the mark of an educated mind to be able to entertain a thought without accepting it. And that's so true. Of course, we are all in this together. Let's fight the illogical mainstream science, not ourselves. I'm not here to tell etherists they're wrong. I'm telling you my perspective on it. And those people who also are etherists or non-etherists, we're not here to get on, fight each other. And I'm not here attacking you. If you're an etherist, I think you're stupid. That's ridiculous. I've told you many times, ether could be correct. It could be the correct model. So let's not fight each other. Let's support each other. Let's talk about this in a logical way and keep an open mind too. Just don't, I see dissidents as closed-minded as people in the mainstream, and it's sad. And we don't want to be that. We are all wrong, and some ideas are just less wrong than others. My dad, I think, said something like that. So I've taken his saying. So let's not fall in love with your ideas, because all of them are wrong. Something better is going to always come along. Doesn't mean that it won't build on what you've done, but it's certainly, you become emotionally involved. That's when you don't do science anymore. So we're wishing my dad's being well. He's working on his third book and on the physics of electronics. He is back at home. Yeah, he had some problems with the heart, but we're in the new normal with him now, and we're really glad to see him. I'm glad to see him back at our family at home. So just a shout out. And of course, our mission is to be an organization that above all promotes critical thinking without malice. That is, if you come to our group and say the Big Bang's wrong, we're not going to laugh at you and say go to school and learn why it is correct. No, because we have the freedom of our thought. No one can put that into a prison and make us think the way they want to think. We're allowed to think as we want to, but we have an organization that supports and publishes and promotes serious scientific work outside the mainstream to provide a forum about modern topics of physics, cosmology, philosophy, mathematics, and other subjects, to provide a forum presenting serious paper and theory without fear of censorship, and to be running entirely by its memberships. If you want to visit and it's your first time watching this, go to beyondmainstream.org. It's our online magazine for critical thinkers. It's really great. I think we've had over 100,000 views on that already. I know for some people that's not a lot, but for us being on outside of mainstream, that's really good. We get quite a few reads every day, so hundreds of people read it every day, and it is done in a sort of a magazine forum, magazine type a publication. So it's not technical. You're not going to go in there and find tons of equations or anything like that. So check that out. It'll tell you what's wrong, what we think is wrong with mainstream science, which is quite a bit. And everything should be up for criticism. And if you want to join in our critical thinking community at naturalphilosophy.org, just go there. You can register and start talking about all the subjects you like outside the mainstream. We're not doing anything like aliens or conspiracy theories or things like that. We're really we let's concentrate on things like we don't know what light is, things like that, small things like that. So that's what our focus is. And of course, we do have a Wikipedia. You can go to wiki.naturalphilosophy.org. It's a true Wikipedia. No, you can't edit it. If you want to add your stuff in there, we'll be happy to help you with that, because an open source like Wikipedia is for consensus. It's not allowed to have dissident ideas. It's then called pseudoscience. So Wikipedia is the opposite of critical thinking. It's the consensus of what we think is right now, and what we think is right now is always wrong, because there are people working on better stuff all the time. Also, it's really vital, folks. I mean, this organization right now is holding on by the string of its bootstraps, or whatever you want to say. We have monthly and annual memberships that you can have subscribe to and help us out. As little as $5 a month, as little as $35 in a year. You can make donations, and right now, without our donations, some good sized donations, we don't survive. And if this eventually becomes to we can't pay for the software and the subscriptions and everything that keeps this thing going, it's gone. I'm not wealthily independent. How much does it cost us? $2,300 a year. That's not much. And I know lots of people watch us. We have over 5,000 subscribers between the two channels that we're broadcasting live right now on. So just think about it. If you like this, it's not like there are 17 other, I'll go to the other organization that allows people to talk about the Big Bang being wrong. There are none. We are it. So please, please, please consider this, making a monthly or annual contribution. Just go to naturalphilosophy.org and you click on the membership. In fact, I'll put the banner up there so you guys can see how to do that. So there you go. You can also donate that. So if you go to membership.naturalphilosophy.org, you'll get there. I know I pound on this, but folks, right now we can't pay for it without some generous donations. And if those people are no longer doing that, we are not paying for it. And you wonder why our website isn't up and running, okay? Or why our server got hacked, which we were hacked for 5 years. People, anonymous in Brazil, decided they didn't like our anti-Einstein, anti-Big Bang or anything. And so now we have to pay a couple $100 a year just to keep our server from being hacked. So all of those kinds of things add up, and we do need it. It's vital. So thank you so much to those people who are doing it as well. Want to thank our patrons, Nick Percival, Dr. Cynthia Whitney, Ramsey is his pen name, all the annual and monthly memberships. Of course, we do need your vital support. Vital means life and death, and that's exactly what we have. Okay. I am looking for hosts and guest hosts. I know Franklin was doing that for a while. He did that for many years, but we're still looking for some people. Do you enjoy talking with other people? Do you have an interest in supporting critical thinkers, even if they disagree with you? If you do, contact me, and I'd love to start co-hosting with somebody, and then eventually have it so that we'll have somebody here every week, and be able to keep up this kind of level, because we do want to keep it at a certain level. We just don't want to sort of come on and, oh, what are we going to talk about today? So I am looking for people. So if you are interested and you like this kind of stuff, hey, contact me and we'll talk about it. Be happy to talk to you about it. Okay, to the main reason why people are here or not here today. I'm sure there's a lot of people that are staying away from this for sure, and that's okay. The good thing is I know the people who are going to stay away are absolutely going to watch this recording. So if you're watching the recording and find out, what did David find? Oh, you're going to have to find out here, and we can discuss it as well. But is modern ether theory dead? Is there a possible fatal flaw? And I've been thinking many years about this. So talk about myself. I'm a computer science. And I do this with other people, folks, okay? I'm just treating myself as someone else. If we had another host, they could do it, and I would be just representing, but I'm presenting myself. So I'm a computer science, an artist. Yes, I do draw. I paint. I was represented by the LA County Museum of Art when I was in LA. Musician, filmmaker. Yep, I made a documentary, filmed about 8 years, and a YouTube vlogger. That's what I'm doing here. And was interested in physics and cosmology after I met Dr. Riccardo Carosani in the early 1990s. Got my bachelor's degree in mathematics, architecture, and my master's in linguistics, and works in the area of AI, specifically with human language, and I'm a co-author of a computer language. Yeah, I wrote a computer language. It's pretty cool. And it's now becoming popular. People are saying, oh, machine learning doesn't do it by itself. So anyways, David is also, oh, yeah, I already said that. I met in 1996 how to get in this, specifically this organization. I met John Chappell because I was wanting to present Dr. Carosani's work. He's the founder of the Natural Philosophy Alliance from 2005 to 2013. I made a documentary called Einstein Wrong, the Miracle Year. After working with my father, and we co-authored a book called Principia Mathematica 2. My dad also had a book before that called Gravity is Not Free. And it's a complete toolkit for hacking the physical universe. Take a look at it. It's for sale worldwide on Amazon, both ebook. You can get it for $3 ebook, and the ebook is really good. Looks great on a phone. I made sure that happened. And of course, I'm currently working in the supercomputing department of LexisNexis, specializing in creating digital human reason I am the president of this group for now. Hopefully, soon someone else will come along and do that. I've done this quite a bit, enough. Here's my personal philosophy about all this. I look for truths no matter what their consequences are. I know only a very few people that really do that. I know people in general want to do that, but a lot of times they'll get hooked on some system in their head or some model in their head, and then they'll work on that. And that's fine, but I guess I'm a little different. Even with our own model, I'm constantly looking outside, looking at new ideas, looking at new models, looking at new ways to do things. And, I really just try to look for what I think is better answers. It's not really truths. It's really just better answers. I give myself 100% ability to be wrong. I don't care about that. I also give myself 100% ability to find better truths. Something, again, I don't see people doing. They sort of get stuck on something. You tell them there's some problem and you got to work on it. And I even know my dad and I have a model. We know what the problems are. I do not attack ideas because I don't agree with them. I think that's probably why a bunch of people probably are staying away today, because they feel I'm going to be out there just, telling everybody, you believe in ether, you're dumb. Of course not. Ether could be completely right on, and I could be completely wrong on this. I attack them to decide if they are better truths for me. And that's what I do. I attack my own model constantly, my own model, my dad and I's model. I attack ether. I attack all the models I know. Jeff Yee has a model. I look at that. I attack. I said, where can this be wrong? Those kinds of things. So, and I also don't defend my scientific beliefs or believe one should do that. Again, even amongst the dissonance folks, I will tell you, I wish I could tell you that we are all this way. And it's really hard. And I think that's one of the reasons when I host these things, I'm really excited to talk about people's models. Like Jeff Yee, it's a great model. It really is. I know Yonel Deneu's working on a model. The people that we're going to be giving lifetime achievement awards this year on during these Saturdays, they do great models. If I don't believe them myself that those are the way it works, that's my belief. Doesn't mean that those people are wrong. It's still amazing. They're still amazing models. People still have amazing ideas. I like models, of course, that are much better and much more physical than they are poetry. I don't like poetry. Man, you see this hat here? I'll remove this here. See this hat here? I wear that hat because I just don't like people talking about systems that are just kind of systems, I can't stand science poetry. Let's talk the physical world. That's what I'm interested in. And we need to keep sort of wide-eyed and curious like children and open to new and amazing ideas, even if they're not our own. I think a lot of people come here because they sit around sort of like, here's my ideas about here's my theory, and I'm going to see, will David say something that my theory can explain, and maybe he'll like that and he'll come my way, or somebody else that's talking will say something and I'll tell them about my theory and how that my theory can describe that, and they'll come my way. Yeah, I just don't see that as a really good way about going about things. This is sort of like sit in a room somewhere with people who are critical thinkers and like to think about these things, and just everything's valid, everything's up for sale, everything's ready to be attacked, everything, there shouldn't be nothing sacred. And it's really hard to find people really like that, because we're emotional beings, and I understand that, but I don't know. I have some ideas about why I'm this way emotionally. My father's that way too. I won't get into it. It's very personal, but we even think about that. And I think my father and I really are like this. There's this joke from I really love. It sticks in my mind. That's very relevant to what I'm talking about. It was the TV show MASH. MASH was a sitcom that had serious side about the Korean War that was done in the late 70s and early 80s, 70s and 80s. And it had a scene in it where, had this, I don't know, corporal, I guess, who was like in charge of the communication of the group. And then the I don't know if it's a major, but the guy in charge, and they're playing poker. And the guy, the little guy in the group, the furthest down the totem pole, won the hand, and he picked up the pot and he started counting all the money. And Colonel Potter was his name. Turned to his name was Radar. He goes, Radar, you can trust me. He goes, I know, sir. He says, but you continue to count the money. He goes, I know, sir. And that's the way you got to be. Just because someone tells you something, you can't. It's that idea that some people attribute to Aristotle, which is basically, you got to keep that mindset of you can entertain something, but you don't accept, but you should be able to entertain it. And I think that's the kind of attitude. So that's sort of my personal philosophy here. So, hello. Why aren't you moving? There we go. All right, full disclosure. Ether as a model for light could be right. I've told you that before. I want you to understand, I'm not here to bash it and tell you you're all wrong. It could be right. I could be wrong about all of this. And I will tell you this. You can say it. I've heard ethers pretend to say it. They don't mean it. And this is not a dig on them. I'm telling you what I see. I'm not here. I'm not going around with some emotional thing. I don't know what it is about people who want Aether to be the model, but you just never hear them saying, well, Aether could be wrong. You don't hear them. They go into giant blast mode of how it's right and huge explanations. I don't hear it. And when I tell that to some people, of course it's going to be wrong, but if you know how human beings, we can sort of detect when a person isn't sincere about what they're saying, that's what I hear. So I'm only reporting what I've seen. And this was before I even had my own model. My dad and I had his own. This was the same way 10 years ago, and we didn't have a model. And I told people, and they knew that. Myself with my own model. This is what I do. I constantly look at other models. I constantly try to find good ideas from other models. I constantly try to break my own model. I constantly try to break other models. This is what we should be doing. This is what engineers do. This is what, you think SpaceX, why are they so good? Because they blow the heck up of rockets. They're going to try something, doesn't work. They blow it up and they go, do you think they go around, well, it can work if we do this, and if I tweak this over here, and if I make them this size, the Aether, this shape, and it goes this, and it's got this magical property. Folks, if it's broken, let's fix it and go on, whatever. Again, I don't see Aetherists doing that. I don't think I've ever heard Aetherists say, your model's well. Not true. One Aetherists have. That was Duncan Shaw. He did. He congratulated my father and I on our model. Only Aetherists to do that. It's bizarre. I don't know why. These are my personal aha moments. This is just to give you an idea. Things that blew my mind right away. Neil Adams, when I saw his Expanding Earth videos, blew my mind. I knew right away it was right. I was just completely blown away. And Yonel Deneau, when I saw his underwater experiments that showed things that look like magnetic fields, I said, blew my mind. I read actually the universal cycle theory, not the infinite. That was before the infinite universe theory or model, whatever he calls that. But the universal cycle theory I read about neo-mechanics and infinity blew my mind. Called him up, talked with him on the phone for an hour and a half. My dad presented in 2015, and I don't remember, April or June or whatever. And he put up this diagram about me, Aether and Aether. Oh my gosh, did I say that? He put up this model for light, and I couldn't understand it. And then he put his hands up and did this, and all of a sudden I understood it, and that blew my mind. And actually, my mind was blown again when I saw some of the models that Jeff Yee was doing for the nucleus and why electrons were staying in the SPDF orbitals, where he was attributing that to the forces, the Coulomb force and magnetic force. And of course, my father design model would say that's a G2 magnetic force. But regardless, that blew my mind. And Aether for me did not blow my mind. So I don't know why. And that's why I'm here. I'm not here to rag on anybody. This is a personal thing. I thought it would be interesting because I did do a survey on my website, on my YouTube channel, which has over 4,000 people. And let me see here what the survey says. I put on 3 things. There it is. Community. Here we go. Okay. We have... how many? We don't have many votes yet because it's very young, but it's got 3 days, 19 votes is all. But I put 3 things down. I believe 100% theory, 100% that Aether exists is one of them. Aether is the best model, but it could be wrong was another one. And then Aether does not exist. So out of that 19, the percentage-wise, 21% say, I believe 100% that Aether exists. Again, this is not from mostly people. These are people who are not necessarily dissonants at all. My channel is full of a lot of people who are not talk about science at the level we do, but a lot of them do for sure. And then the second one was Aether is the best model, but it could be wrong. 37%. Yay, that's good. And then Aether does not exist. 42% of the people, almost not 50%, but 42% said that it doesn't exist. So that gives you an idea. So even though we are in the dissident world, we're not in the majority of, in the sense of ether exists. And if you look at our organization, the CMPS, for people who have models, the ether model by far is the most popular. Here's some principal objections to ether. Of course, laser light. How do you have laser light go through a medium? It's like saying I'm going to shoot a sound wave that's going to be a 1 inch wide and go 20 miles. Yes, it does span out. I do know, folks, you shoot a laser to the moon, it spreads out to be at 2 miles, but it certainly keeps within it doesn't follow what waves in a medium for sure. That looks much more like particles. And of course, you have the wave-particle duality where etherists tend to ignore the particle properties or claim to solve them, which I've not seen a good explanation for it. I have seen attempts, but not good ones in my opinion. My opinion, folks. And then while most particle models ignore the wave properties, not all. So the big question is this is from my own curiosity, really. I don't believe ether is a good model, in my opinion. It's just there's too many problems with it. I think I've talked about this before. I think it comes from a fixation that we want to make physicality for light, and from there we say that's the only way when it really isn't. Now we have a absolutely, in my opinion, way better model now than that, which didn't exist too many years ago. But again, it's my opinion. But I personally, like 42% of the people in my survey, don't believe ether is a good model. Could I find a game stopper, one that would finally get me to a point where I say it's dead to me? Right now, even with this game stopper, I've only come up with it in such a short time. I can't tell you if it's done that for me, but it may. I have to let it roll around my mind. I think about it every day. Well, I used to think about it most every day, whether ether was correct or not, or something like my dad's model for light is more correct, is a better model. And of course, I have been searching for a killer argument for many years, and I finally, talking with my dad, who just didn't care about this, to be honest. He's like, why is my son talking about ether? I don't care about this, because he's got a lot of how do you say, things to do with his life, and great research, like this one experiment we're going to talk about. So anyways, this is the reason I'm asking this question for me, okay? And what ether I'm talking about, and I'm going to talk about this before I get to my explanation, because I'm going to tell you what's going to happen in the explanations that really make me mad, because I'll talk about it, but let's go follow my slides, Dave. What ether I'm talking about. I am talking about ether as a medium, a luminiferous ether. It doesn't mean it can't describe gravity. Okay, I'm going to say that 5 more times. Luminous. When I talk about light as ether as a medium for light, it can do everything it wants to. But I'm talking about light, and I'm talking about ether, and I'm talking about the idea that light is waves through a medium. That's it. Okay, nothing else. That the medium in which light waves propagate. Now, if you go to the average person who knows science a little bit enough, they're going to say that. Okay, and I'm going to get into these other arguments that I hear constantly from etherists. It's not because I think ether is wrong. I don't like bad argumentation, folks. I don't like it. Physics, please. Okay, what it is not. It's not the material that fills the region of the universe beyond the terrestrial sphere. Why do I say this? Well, that's what ether was before they talked about luminiferous ether. The ether is out there. It's drifting in the ether, where people start redefining, or at least redefine. I'm talking about ether as a medium for light, and whatever else you want to put on it. If you want to make it do gravity and magnetism and all that stuff, more power to you. Okay. I'm not looking at this as some poetic interpretation of the word, and it's something that is not a medium. So if it's not a medium, I'm not calling it ether. Look, I study words for a living. One of the things about people with words is they become poets. And what we try to do in all languages is try to come up with a word that means something so that when we all say it, this is what it means. Okay? So it's very important. One of the things we learned in our organization, try to understand how the person talks. Okay? What we use. What I am claiming is that if you would get 100 scientists who know what ether and have heard of that, they're going to most all say that it's a medium in which light, supposedly the waves are propagated. They'll probably mostly say too that it's been discredited, but that's a different story. Okay? This is what I mean. This is what I mean. This is what I say ether is. Okay? This is pretty simple. This is what sound does. This is what water does. This is what ether does. It's a medium where you have waves through compression and rarefication. Watch the particles. See this red thing going back and forth? It's not moving around. Very crucial in my argument today. So you can see these little red particles here and there that are staying in basically in some place, and that you have waves going by. This is a wonderful diagram. This is the physics definition of ether to most people. Okay? I can hear people screaming at me already. But believe me, I got slides coming up because I know these screams are coming. My guess how many etherists feel right now. Very angry at this entire topic. Angry at me and consider me arrogant and disdainful of all people who believe in ether. I'm sure there's some people like that waiting for the supposed fatal flaw to show how this objection is wrong without even truly understanding the objection. That I believe. That I believe is going to happen. And I'll tell you what else can happen as well. To me, starting to get closer to the flaw, this is where I started to think. This is where the flaw originated from. This idea. And I know I can hear people screaming, Dave, this is the way old ether is. This is old ether. It's not. We're going to talk about that as well. I'm talking about luminiferous ether. If you have a medium in space with light going through it, it is some kind of reference plane. It's got to be somewhere. The Earth's going to go through it. The sun's going to go through it. Yeah, there may be wind with it. If you believe in magnetic fields, as Yonel does, Yonel Deneau, who I think is a great scientist, who gave the world a great thing. He's an etherist. And he says that magnetism is the circular flows coming together of particles. In this case, he calls them ether. Of course, if it's ether, then if you have circular particles, then magnetic fields should bend light. That's another problem, but I won't talk about that. So anyways, space to me is empty, is a place where mass goes. Yes, out in space, it's full of stuff, but there's space and there's stuff. Okay, folks? All right. All right, that's what I'm talking about. So space isn't a foam. Space, the reason we have the word space in language, and not only in English, but in thousands of languages, there's the word space. And that's is a thing to call where there is nothing. Yes, we thought in the beginning there's nothing, but we feel air, we know there's something there. In space, we know there's stuff there. I'm saying that ether in space has to be, if there's the Earth and sun going through it, it's got to have some kind of reference frame. And there, in one of the problems, it lies. Now, that's not the problem, though. It just points to the problem, in my opinion. So, ether compared to wind, stationary compared to what? Oh, but it's not modern ether, Dave. It's not the way. We're going to talk about that too, because that's a run away from the problem answer. Okay. Mainstream, of course, killed it, supposedly, ether. Einstein says ether is not needed. He postulated the photon. Of course, people say photon can't work because it can't show wave properties, but of course the double slit experiment where we supposedly shoot one particle at it, that I disagree with that idea, but even if it was one, you can't explain that interference pattern. Some other people can, some people yes can, but in this case the ether, it looks really great for the double slit except for the particle side. So again, if you ask 100 physicists from 100 universities, ether's dead, luminous ether is old. The photon is there. It's got a wave. particle duality problem. We can't do it. But ether does not die among the dissidents in the 20th century. There's what I would call a fixation on the Michelson-Morley experiment. I really do think it's a fixation. If you have a model for light, who cares about that? You can explain it, yeah, but I would tell Michelson, everybody fixated on Michelson-Morley, do you have an explanation for light? Oh, it's ether, great. Okay, then answer, let's get over the objections that are real objections. Just tell me how laser works, first of all, before I go worrying about whether you can explain Michelson-Morley. So there's some fixation on that, and when I think we should be looking at other things. There's also some kind of fixation of explaining gravity with ether. I don't know why. I don't know. It's sort of, I think a lot of that comes maybe from the idea that I believe in ether, so it's so great, and it's just a model we've been trying for 400 years, and no one's got it. But besides that, we got 400 years. It's there, and not only that, we can describe gravity. So it's got to be a great model because it can describe gravity as well. And of course, ignoring the problems with ether, which they do. I never saw a paper by etherists say, this is how, oh, no, that's not true. I saw a laser, I saw on the internet, I did see somebody with some like spiral kind of thing. So at least they're trying to address it. So that good, kudos to them. What I'd like to see etherists have, entertain objections without, what attitude etherists should take. Entertain objections without accepting them. Yeah, you don't have to accept them, but you should entertain them. And I think most just, reject them without truly trying to understand the objection. That's my opinion. Know that all theories and models are wrong. I wish etherists would say that. They would be less, so darn certain of it. And acknowledge that there are other valid models out there. There is. My father's got a model for light. It's really good. And it solves the wave particle duality. It's not perfect, no, but there is another model out there. So it's, before we didn't have one that was really a legitimate contender. Now we do. So at least admit it. Yeah, I'm an etherist. I believe in the medium and waves going through it. These are my properties and stuff. But yeah, there are other valid models, and this could be wrong. I wish. There are people in this chat right now that will not say that, and they're etherists. So, all right. I'm making enemies left and right. And it doesn't matter because I could be totally wrong and all you etherists could be right. So, but that doesn't bother me. There's no emotional attachment I have to that. Bad arguments against ether. This is one I came up with last night. It was, I think this early this morning, like 5 a.m, and I write myself emails so I don't forget this. Changing the physical definition of ether. Dave, you're talking about the old ether. I'm talking about the new ether. Well, no, I came up with this, shift the name, shift the blame. That's what you're doing. That's a really good saying. Shift the name, shift the blame. What does that mean? Oh no, Dave, the problem with ether with lasers, that's because that's the old ether. It's not the new ether. We don't have those problems. Well, tell me how to explain it. Well, and then I hear science poetry. That's the second part. Using science poetry and not logic. And then I hear all this poetry about it, and I'm trying to get a physicality on it, and I'm listening to it, and it's got energy, and it's got, fields that people, and I said, what's that field? And they said, it's field. It's got charge. And I said, well, how does that charge? You put pluses and minuses, and there's a magical thing in the universe that makes them come together. It's just full of poetry. But when you shift the name, that is, if you say, oh, that objection doesn't exist because the ether I'm talking about is this ether over here. It's no longer ether. You're going to have to call it something else because ether is a medium. But I don't think that's what's happening. I don't think people will call it something different. I think they're just shifting it over this way to shift the name, shift the blame. That's what I think is happening. So talk about why ether is correct without addressing the objections. That's another one. So I want to go up and I'm going to tell you this fatal flaw. People are going to come on with me and they're going to live or in the chat and say, Dave, ether explains everything. And then they go into this long explanation. And what is happening? Let's say we're in a debate class, right? We're in a university debate class. And the debate is is this objection to luminiferous ether valid? And so the person gets up there, myself, and I give you my objection, which isn't here yet. And then we get up there and everybody's talking, and it's like, I talk and I give you my objection and I rest my case for that part of it. And then the next thing is there's a rebuttal. So the etherist gets up, and this is what happens. I get emails, I get texts, I get comments on, I already got comments on this. I got people literally doing this. They come in and go, you kidding? Ether explains everything. And they go and explain it. There's no objection. Of course, they don't know the objection, but that's what's going to happen. So the next person in this university during this debate gets up and says, oh, by the way, ether can explain everything. Look at this, it explains this. And I have a theory of ether that explains this and this and this, and this is how it works. And they get into this explanation. And then that part's done. And let's just say it was just the two-part debate where you do present and the person goes, and then you're judged. Basically, what you would do is get a failing grade. And the person's going to say, what are you talking about? This, ether is right. I just explained it. So that wasn't the question. The question was, David de Hilster posited an objection that he sees as a fatal flaw in the model, and you never even talked about it. Or the other one is what I call sort of the Star Wars Luke Skywalker effect. You have this big looming objection, and this is what the mainstream does to new models all the time. Models like Jeff Yee's model, or my father and I model, or Borchert's model, or Lionel Deneu's model, or all the other models that are out there. They come in, they look at it, and they see on line 45 an equation that doesn't match the equation for mainstream. Look at line 45. It's flawed. The entire theory collapses. And that's the other idea. You make an objection, a person supposedly has an answer to it. Nope, that's it. That's fatal. Your objection is completely explained why it's wrong. And they do a very cursive, sort of high level, try to attack and then go back into their explanation how ether is right. So look, I'm not making these things up. I didn't come up and try to make these things up. I've seen these for years and years and years. My goal here today is, as a person of the 42% of us who don't believe ether is a good model, I'm trying to give you my perspective on it. And you guys could be right. Oh my gosh. All right. Reasons for ignoring objections. They have no answer to an objection. That's one of the big ones. If you have an objection, like how do you do laser light, and then you hear a tirade of how their ether model explains 1,000 things, and you go, what about laser light? Maybe they don't have an answer to it. Instead, what they should say is like, I don't have an answer to it. That's a great question. I think an ether model, there's perhaps a way we can do that. I haven't found it. Oh my gosh, that would be the most wonderful thing to hear from an etherist. I would just, I don't know what I'd say. I'd buy you lunch. Don't take time to understand an objection. That's true too. Have fallen in love with ether, emotionally invested, have invested too much time and emotion to ether to give it up now, or to look at its problems. So these are my observations again. So here comes, dun, 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 dun. It's coming. So let's get to another banner here, because I don't know if anybody wants to come on, but there we go. Take this banner down. Again, if you can like and subscribe, hit that like button if you're liking what's going on. Okay, hit the subscribe button. Let's get to 1,000 subscriptions for the CMPS organization, and keep hitting those subscriptions for my channel, Dissident Science. If you like this, there's no place in the world where we even talk about this or open debate with this. I've got people in our green room that have, a great hatred for me. I know all those people. I can see them shaking their, I'm kidding, of course, being totally sarcastic. But anyways, here it comes. Medium. Ether, in the way I'm talking about it, and if you get 100 professors from university and they talk about ether, they're going to talk about it as a medium. We're not talking about shift the name, shift the blame, and come up with poetic new names for it. We're talking about it's a medium. That's the idea of ether. It's simple. Light is a wave through something. Now you can give it all the kinds of properties you want, but in the end, it's a medium. Liquid is a medium, but it's held together, and it's held together by atomic polarity. This is the crux. This is how I got to the argument. Solids. Solids are held together by atomic bombs. Well, that's what we call a garden path sentence in linguistics. You say it so many times that, atomic bomb, and you see BO, that your brain just spits that out automatically. It's atomic bonds. That is a solid, the atoms are tightly connected, and liquids are done so a little more loosely, but also they also use gravity. Liquid also, I didn't put that as well. Gas is held together by gravity or some container. Same way with liquid can be that way as well. But even in space, though, if you notice, if you put water in space, it makes a sphere. So that's the reason I did that. So held together by atomic polarity, basically what people call charge. Some models can explain that, numerous models. But anyways, this is a medium. So light are waves through a medium. Waves in the ocean that you surf on are waves through a medium. It's a liquid. Sound that goes through, if you tap on the end of a solid iron beam, you can hear the waves will go through that beam. If you are in a gas, that is, you're standing on the earth and you have the atmosphere, you can make waves by vibration, and that vibration hits things just like that one diagram I showed you, and waves are transmitted. If you go into space and you try to talk and listen, there is no sound because there is no medium. So for light to travel through empty space, yes, there are places in space that are empty, and it's all filled with stuff, I know. Gosh, I just hear people yelling at this. So this is it. So is the next slide it? Maybe it. My objection. Yep, it is. Here we go. Ether as a medium in space. The fatal flaw is there is no force in space to hold together ether particles to make a medium. Therefore, it is not a medium in space, and waves can't propagate through it. There's no gravity holding ether against a body in space. There's no atomic structure or attributes to hold ether together. Particles in space, when they get moving, we know by Newton's law, they'll move and move in that direction forever. The reason we have waves in a medium is because there is a force that keeps those particles together. Otherwise, if you go to the edge of the atmosphere, you don't have the oxygen, all that atmosphere necessarily staying there. Some of it escapes to space. So that's what I was thinking about, and I finally got to it. And it's interesting because I subscribe to Borchert's work, which is motion, all mass is in motion, and there's no mass without motion, there's no motion without mass. And that when a particle in space that does not have any kind of force or container, yes, if ether got close to it, but even if ether gets closer to a body, what's keeping it? Well, people say, well, other ether, well, if it bounces off, it's going to eventually just be like gravitons. It's going to go in random directions and random ways. Why is it going to only hit its own particles? And what does that mean? So that's a problem. And of course, you have the whole problem of, if ether is in space, is there a frame? What's it staying, if it were to somehow have a magical force that kept it together? How come you have, the earth going through it, or that the medium is there so it can go through it? Because if the particle of ether, it's got a slower speed, why is that? Again, it should not stay in one place. Ether is stationary as compared to what? So my contention is ether, any particles in space, as what we talked about ether, what people in their minds were not realizing when they thought about it was that all the waves that we know through a medium are with particles that have some force that keeps them together so waves can propagate through them. Otherwise, you have a gravitonic field, what my father and I call gravitonic field, or gravitons, which is random particles in random directions. And yeah, they'll hit each other once in a while, but they're certainly not a medium, unless, I don't even know. I don't know how you can do that. So that's my objection. That's where I just came up with probably a couple of weeks ago. It just hit me like a ton of bricks. I said, What is keeping them together? I said, what is the difference? So what we have in our head is we know of the way mediums can propagate through. Waves can pop through a medium. We know then if we haven't thought about is mediums require the particles to have force that keeps them together. And if that exists, then you can have a medium. I say in space, you just can't do it. So there is no ether because there is no container. Yes, that's what I'm saying. Yep. Because if you put stuff randomly in space, it's going to go randomly around. You're not going to have an ether. It's not going to stay around to transmit. This one particle isn't going to stay there, as in this one graph. Let me go back to it. It's not going to be doing this. The ether particle in the middle of space isn't going to be doing this. It's not going to be happening, in my opinion. That's what I came to as a conclusion, trying to come up with some type of is there a fatal flaw in this? So that's what I came up with. So that's the fatal flaw that I see. It's really weird. I mean, it's pretty new. I've never seen that argument before, that ether can't be a medium in space. And particles can't be a medium without some type of force between them. Okay, so conclusions before I get into people talking about that. Talking about this, and I'm sure wailing on me. And again, this is just my opinion. But this is another thing that I will say. The best minds on the planet for the last 300 plus years have tried to solve light and gravity with ether medium, and no one has proposed a satisfactory model that addresses all the posited objections and that would allow everyone to embrace ether as a viable model. That's true. This is a true statement. And I think people, if there was something that was really there, that some tweak would give us, then it would have happened. That's my opinion. Because, I don't see it. And with this objection, this idea that you can have a medium in free space where there's nothing that keeps things together, and that we're traveling through this, it'd be like traveling through this pudding or something. These old kinds of things, like, and what is ether staying put to? How is it not? What is it? I can't even answer that question. I want somebody to answer the question: how ether stays in a place? How does it do that? So, one or more tweaks on the ether model will not magically save a fatally flawed theory that cannot be a medium in space. That's what I'm saying. Particles in space cannot be a medium unless you imbue them with magical properties, or you say that those particles have these attractions, and this is the physical reason, not because I put like positive and negative on it, because those are arbitrary attributes with arbitrary properties. But that's my article. That's my argument. So anyways, I'm sure that, people, if you want to talk with me live, I will absolutely make your argument. I will come back at you if you tell me how ether is so great and not talk about the objection. The idea would be to talk about the objection or objections, or to, again, imbue or shift it and say, Dave, ether isn't this. No, ether is this. This is what I'm talking about. So if you're talking about something else, that's great. And call it something else. It's not ether. Call it the Hue particle, like Franken Hue, or call it the Garnath particle, or the Hilster particle, or the Keen particle, or the Cricket particle, or the Cohen particle. Don't call it ether. Ether is the idea is light is a wave through a medium. And I say in space can't happen. It's not a medium. So anyways, no one wants to talk to me. I'm sure it's like, I'm honest. I just thought of this recently, and it's intriguing to me. And I will tell you right now, everyone to the camera, I'm not saying that I'm buying this yet. I think it's pretty interesting. So let's see. I did on a presentation of David's video. Okay. Anyways, We have people here. James Keene is smoking because he's just like, I'm not coming on talking with Dave today. Um, Franklin Hughes, who's an etherist, is there, and and we also have Ian Cohen. I have Taiwan Cricket is here as well. If you do want to speak to me, we do have, if in the blue room, you can go to live.naturalphilosophy.org, and you can get on the air. And I'm absolutely willing to let you talk away. I will come back at you with a response, but I will let you freely talk about something. Okay. Anyways, let's see, what was it? So there is a private comment because I know I don't see Taiwan Cricket. I know you don't have something there. Oh, there, gravity is what you're looking for. Okay. So, anyways, would somebody like to come on? Hey, Ian, I know you're up for it. How are you, Ian? It's good to see you after so many weeks. You know, my dad's been
Yeah,
not doing so good, so I've
I
been,
heard about that from Dennis Allen, and
yeah.
I was sorry to hear that, but I hope he's recovering. And unfortunately, I was just otherwise occupied. I had to go down the country on some tours. That's why I couldn't make.
Well, it's great to have you back. I've always enjoyed talking with you. You're a big thinker and very open-minded. So, have you, this whole idea that, first of all, are you a person that said, yeah, ether should be, and we should describe ether as a wave through a medium? Is that something you subscribe to?
Well, the short answer is probably yes, but my first comment was going to be that I sort of might refuse a quarrel, between etherists and non-etherists per se. Um, so I made a few notes here, David. Obviously, I totally agree that one must be open, totally open, and though if I may gently suggest, I think there might be some possibility of interpreting some of the journey that you've undertaken as what many of us have done. I'm sure I'm not immune to it either. Forming a view ab initio as to whether this is acceptable to you, almost emotionally or philosophically, and then sort of
Right,
finding arguments to justify that.
right,
So
right.
I just thought you might want to come back on that. Now,
Sure.
but you see, my fundamental point here is about all these models. I'm not sure if I use this. I'm actually skeptical of all models. The atomic models and these models and those models. What I do is, if I have a complex phenomenon in nature that I want to describe, in other words, I can perform a few experiments with it, but I cannot perform an infinity of experiments, vary all the parameters and so on. Well, what I do is I make a mathematical model. I find how the system behaves experimentally, and I extrapolate that to, partial differential equations or something, and I make a mathematical model, and then I plug in certain variables and I see what the outputs are. To me, that's what a model is. I don't view the ether as a model per se. I view it, and this might be a little controversial, but I view it as basically like a gas or like air. I mean, you might say you measure the atmospheric properties, and you find that it has certain density and certain pressure under certain temperature conditions. So you have a model that there's oxygen there or that there's air there. And then if you have another container with hydrogen, you find different properties, and you have a model for that. Well, I don't even formulate a model for this at all because I'm skeptical of all models. I say there are properties which are inherent. We do measurements. We perform electromagnetic measurements, and we find that there's a sort of a capacitive value and an inductive value. You have the permittivity and the permeability of the medium, and you have a wave resistance. You have a wave impedance, if you like, to alternating current, and you have a speed, sort of a Newtonian type speed, just as like you have, say, the pressure divided by the density of the gas. You take the square root of that, or you can bring in the adiabatic constant to make it more accurate. Yes, and here you have the same thing. You have a square root value with epsilon naught and mu naught. So So just to get back to this controversial statement I'm making, which I'm sure you'll want to come back on, is the half dozen models that you applaud very much are all models. I sort of dismissed them. I'm sorry.
No, that's really interesting. You know what's interesting to me isn't that I would argue against that, is that I didn't really even think of that. Basically, what you're arguing is that the only important thing to you is the empirical equations we come up where we can do things with and make predictions with. And we do that all the time, right? We actually have in human history made electronics, made all kinds of things without any type of idea of what's really physically going on, right? We don't know. We talk about, for instance, electricity, and it's ridiculous because you'll hear things, physicists talking about electricities, and all of a sudden they'll talk about, and the holes left behind as these travel in this direction. And you think about it as a physical, you just think that's bonkers, right? It just doesn't make any sense. But if you then look at all the equations, the empirical equations that my father, for instance, used very brilliantly through his life as a person who was in electrical engineering and research and coming up with new digital equipment, they didn't need to know what was going on. And I think I would say to you is that it's not important to you. The same way that to me, I can't stand the idea as a mathematician, because I got my degree in math, I can't stand not knowing what is it really? We know, for instance, we do know some things, for instance, right? Atomic structure. We can now see and really understand the way atomic structure works. Yes, it is sort of a model. I guess my comeback to you would be, that's kind of got a lot of evidence as to at least the locations of stuff. It doesn't say how it really works, but I mean, you don't call that a model. The atomic, what would you call the atomic, the table of elements? What would you call that?
Okay.
That's not math. That's not mathematics.
Yeah, but it's distinct from, say, the Bohr model or some model.
No. What I'm just saying is I think you and I would be in agreement that copper exists, that silver exists, that argon exists, right? I mean, do you agree with that, or you don't?
Well, obviously, I do agree, and we can catalog these in terms of properties. I mean, it's a microscopic way of categorizing things. Just as we categorize wood and iron as having different strengths and so on. Yes, that's what the periodic table is. It's all these elements categorized in regard to their properties.
But is that that's not a model then?
No, to start, when the chemists start waxing lyrical about all these shells and this one is that, and the halogens have this in common, and there's some blanks here and so on, I just say, let them away with that. If that gives them their results, fine. But I don't take it very seriously, to be quite honest.
But here's no, I understand. Here's another interesting argument. This is very interesting. I'm loving this discussion here. But here's what I would say too. Here's not a counter argument, but an interesting part of this conversation between me. I want to know everything physically, and you don't care. Give me the math. I'm happy, and we can do all we need with it. If we have a model, and that model, for instance, like we have for our model for the particle model, we call it, right? And we apply that to electronic circuits. And now we can understand, my dad can explain why in a transition, a transistor is doing that, and what forces and what's going on there. And then that allows us to predict a measurement that electrical engineers never saw because they weren't looking for it. And it was very small, but we now have that. Isn't that somewhat at least saying, okay, here's a model. We've applied it to electronic components. We are now making predictions. Another prediction we're making, I'm not going to tell about because it's really amazing. It's about magnetic fields around a wire. Very simple. And any student in any elementary school can do an experiment to show something new. The only reason we have that is we came up with a model, a physical model. We thought about it that way. doesn't that seem to be worth something? Because even in the end, if we get the physical model for the magnetic field that's much better and more precise, or that we have measurements where we know that there are these relationships, that when you have that current between in parallel resistors isn't the same as everybody says it is, that there is really a small difference, and this is the reason why. If there's that model and it then makes these predictions, and then you can make empirical equations for it, doesn't that make it a valid idea that models could then be really useful?
Well, they're certainly useful. There's no doubt about that. But whether they represent ultimate truth,
Well, yeah, they don't represent. I would say they represent more truth than the one before, right? I mean, that's what I would say. If your model makes a prediction about of something that wasn't measured before or looked at, and in fact is there, and that regular explanations with the regular physical model of electronic circuits can't do, then yeah, I mean, then you've got a model that's, it's just not just doing things. It's not, it's like, oh, you don't know what's going on. There is some idea of what's going on. If we then have a model of what's going on in the subatomic world that says these are the things moving, and then we can make empirical calculations, we can go way beyond what we're doing now technically. Isn't that something? Or
it's a better predictor. But I wouldn't confuse, even the success in prediction with ultimate reality. These are philosophical questions, and I don't think we can get to the bottom of them. Where we distinguish between mind and matter and what ultimately these concepts entail, and therefore I have my skepticism about all physical models.
Sure.
Science.
Oh, I do too. Yeah, I do too. I understand that point of view. I really do. I think it's a valid point of view, but I also think that models will help us get to those things. And I mean, here's the way. If you look at the way I look at the world, I think it's, there's infinity up and down. The idea that one particle could magically just start holding hands and dancing and create the universe, that's pretty hard to believe. I believe that, the infinite stuff below it affects the stuff that makes these things happen now. But if you try to get it, let's just look at today's model, right? You say that solid, I can't put my finger through the hand. Well, why is that? Well, this is mostly space. The atoms are mostly space. What's really happening? Well, atoms supposedly are made of subatomic particles. So even protons are not solid. So you keep going. If you believe in Borchert's infinity, you'll never get to anywhere, right? You'll never find that solid. And in that sense, I agree with you. You're looking at wispiness, right? What is it really? So I understand. That's really interesting point of view, and I totally can accept that. I mean,
so perhaps I was right in my initial statement that even though on the face of it we appear to take opposite sides, there isn't a major difference between us.
No. I think what happens is people have an inherent way they want to look at the world somewhat. My father and I are very physical. That's the way we seem to, that makes sort of wired in our brain. Other people, it's more just the systems, right? What's going on? What can you do? What can you predict? Can we take something and manipulate the world, what we call physicality, and who cares? We're never going to get at it. Yeah, that's absolutely true. We're not going to. All we can sort of do is in our local world, make equations for the things to do in this local area and hope that that's going to be a useful thing. And as we, have more predictions or come up with what we call less wrong models than the ones before. Instead of 4 elements, there's now 103. Yeah, we don't really know what they really, really are, but we get further and further down. So yeah, I just think it's just different wiring, and I don't know what the answer is that a physical model like my father and I have come up with, even though it could be very explanatory, at least in the near levels that we have. Is that really what's going on, or is that just forces that eventually that yeah, it will help things, and it makes us be able to make our equations better. We can explain, for instance, diffraction and in dispersion, rainbows, and the pinhole camera, and the wave particle duality. We can finally explain that in some kind of model. But in the end, is it really that? Yeah. Okay. Well, yeah, I do believe we're. I just think people are wired differently, and yeah, I think they're
Maybe
in the
we're
same
almost
place.
coming to a sort of duality. Just we talked about the wave particle duality, a duality between a sort of a medium and a particle, and we're sort of like considering one on Mondays, Wednesdays, and Fridays, and the other days, as I think Sir Lawrence Bragg said about the wave particle.
Yeah, yes, exactly. Okay, all right. Well, that's very interesting comments. Thank you so much.
Well, thank you.
Anything else? Anything
Well,
else in
maybe
your
just before I
notes?
leave you, I just
Yeah,
made maybe two or three other
absolutely.
points
Please,
just
please.
quickly. Maybe there are only two. Uh, just when you're talking about the laser, well, that was an interesting point you put forward. But I mean, I just view that as uh, radiation within a medium, which happens to be coherent. All the elements are actually in step. So I'm not sure if I saw a major problem there. The other one was sort of fundamental in your thinking about force holding particles together and so on. And again, I would just pray that one considers that one doesn't have the ultimate truth in these matters any more than one has with regard to a field, maybe an electrostatic field or something. What holds all that together? So those are just my quick reactions to the other points you raised. But thank you
Right.
very much for it was most interesting.
Yeah,
So
yeah. Thank you very much. I really enjoyed your point of view. Thank you so much, as I always do. So thank you. All right. We got other people here in the green room. Anybody? Oh, there's Franklin. Hey, Franklin, how are you? Really good to see you. Nice to be back on air and see everybody again after a few weeks.
Yeah. So yeah, let's get back. I mean, that's an interesting objection I think you have there. So I've not really heard of that myself, but I want to make sure, like you said, that I understand what the nature of the objection is.
Right.
So
Absolutely.
it would seem that your hypothesis, well, the hypothesis of ether, which is just made out of particles,
Right.
those particles have to be close enough in order to have a compression and a rarefication.
Well, not yeah. That's close. It's not close enough, but stay pretty much in a place,
The
right? I mean,
states there, yes, they move
because
back and
otherwise,
forth.
I claim that a particle in space will travel in that direction forever unless it hits something else. So there's no magical thing that says we got to hit each other. I mean, graviton is a good one. So yeah, that's the idea. I think you had mentioned that. Go ahead. So yeah.
So, but the basis, I mean, I found that kind of unusual. I have had a little bit hard time wrapping my head around that. But the basis of the objection is that if that were true, then there's nothing keeping these particles together, so they should just all evaporate. They should just.
Well, no, they just go in different. You can't have a waves through them, right? You can't have that because for waves to happen in a medium, the medium has to be stable. That the particles themselves of the medium cannot be traveling in just forever directions. They have to be in a local place and stay in that local place. And if you look at again gas or solids or even the atmosphere, if you go out in space, in the edge of space, those particles aren't staying there. They're not coming back down. The only thing that keeps them to the ground is another force called gravity. So that's that. And then what I was saying is once the ether is out in space, there is no magical force to keep it contained, which you need it to be contained in order to transmit waves through it. So that I agree. I've never heard of that. It was only a couple of weeks ago. So yeah,
So you
that's
would
the
say
idea.
that air qualifies as a medium for sound because it's say gravitationally
Yes,
attracted.
it is absolutely. It's between the Earth and gravity, and it's
But once you
staying there.
get beyond the Earth, then I mean, do you believe that you say the universe is infinite, so that there's just
Yeah, I do. Yeah,
space
I
for
do.
everything to just
Yeah, yeah. I believe there's no
expand
end.
out
Yeah.
into? So your prediction, you're saying that there cannot be an ether because if there are any such particles, they would have all escaped.
Well, they
Uh,
don't escape. They would just be traveling in random directions. So you couldn't, they're not going to be staying around and hitting and transmitting this wave in this line towards some object or in some direction. Because they're not going to disappear, though they turn into what would be
I'm
called a
not sure I
gravitic field.
understand that part of it. I mean, because it's like air is the particles in the air are moving at something like, I don't know, like 900 miles per hour at 70 degrees. And so they're not staying still like
No,
that.
they're not staying
Yeah.
still, but they stay there because they have to keep transmitting waves. That's the way it works. If these things are just flying off and not hitting it, the reason they hit each other is because they're contained. Gravity keeps them there. They hit each other and they stay around. Because they don't. You don't have an oxygen, an oxygen molecule or element of or whatever whatever molecules in the air hit something and then like in space just keep going somewhere after that. It stays around because gravity's pushing it down, friction's pushing it down, there's all kinds of things going on, whereas in space you don't have that. So that's the idea. Yeah.
Well, I'm not quite sure. Once again, it's like that would kind of be the difference between a liquid and a gas. So if you're looking about a liquid and you've got a wave, then clearly the particle is probably just doing this. But if you're talking about gas, well, the particle is probably doing this.
If you go out to space, throw 1 cubic meter of gas into space, and then try to talk through it and get waves through it. It doesn't happen. It disperses.
Yes, although I did see this very interesting YouTube, and it said that even in space, there's sound. It's at a
No, there isn't.
Frequency.
There isn't.
But
no,
there is that they've measured it, is that there's actually enough atmosphere in even deep space to support a sound wave. So I was just kind of wondering whether
everything I read, I did read that before this talk, and I could, all I got was there's no sound in space. So, but again, I guess the idea would be, one of the things you did say that I thought was very interesting in the comments that you made was that, well, if you have an ether that has some types of properties that keep it closer together, then you have a medium, right?
Yeah, it's like if you had like a cube of iron, right? Now, does that cube have any container?
I don't understand the question.
If you have 1 cubic yard of iron, does that have any container?
Yes, it does. It has the atomic bonds that keep it together.
Okay, so
and that would be, I guess you would call it Coulomb's law. I mean, it depends on the model you have. Our model, my dad and I's model, would call that the new effect, basically. But yeah, they stay together. And again, it depends on your model. In our model, it's F2 gravity, it keeps it together, but that's our model. It depends on the model.
Yeah. So, but we're talking about whether this is, say, a fatal flaw against the ether thing.
If you can't keep particles together in space, you're not going to have a medium. I don't think that's really, in some sense, arguable. You can't have, for instance, gravitons, which are basically particles that move in all random directions. It's not if they're going at the speed of light, you're not going to have waves through them, because the waves are going at the speed of light and the particles are going at the speed of light. What are you going to do? So that's one thing. So that's what I'm saying. If you can't, ether cannot be a medium for light, because it can't be it will not be a medium in space unless you imbue magical powers to it. That was my. There are
some etherists who support me. Me personally, I don't think ether is a solid, but there are some people who think that, right? So
there are people who think that there's a lattice. Who was a lattice person? And again, I'm not going to argue against that. I guess Ron Hatch. Ron Hatch was a lattice person.
But I mean, if you consider that, though.
Yeah, no. But that to me is not an ether. That's a lattice. That's a lattice model, and that's not an ether model. The whole idea
get back to your definition, which is the ether is something which is compressible. Although it's, you showed it more like a random kind of, more of a gaseous kind of thing. So I mean,
the whole idea, from what I would say, if you get
into the renaming things.
Yeah, we're going to get into that. Rename, shift the blame. That's what's going to happen. So this is like Alistair Riddick, who's saying here, well, we're talking a specific conceptualization of ether. The whole idea of light is a wave through a medium. That's what I'm talking about. And that's what we use ether for. If it's something else, let's call it something else. It's a lattice. It's I don't know, the Zombo particle that has properties that keeps it together, it's no longer, what we call ether.
Yeah, so that's an important distinction. So what you are showing in yours is more like a particulate gaseous.
It's a
idea
no,
that
it's not
I-
gaseous. It's a medium through which,
the
ether.
light
That's
waves, right?
yeah,
We have lights, and it's light transmission through a compression rarefication process.
right. Yes, yes. But I'm trying to use what I would consider, if you got 1,000 physicists together, that's what they would consider to be the word EATHER or ETHER. That's what I'm talking about. We have to understand that. Yes, if you have a different model, it's a different model. We would have to call it something else. A person in science would say, that's a nice model, but it's not an ether model, so give it a name.
So you would not consider, I mean, I kind of find that curious that you wouldn't consider it a lattice.
Oh no, lattice is a lattice. That's why we call it a lattice. It's a lattice. In fact, if you ask Bruce Nappy, he proposed a lattice model. If you ask, is that an ether? He'll laugh at you and say, no, it's a lattice model. It's like calling my dad's model for light a lattice model or an ether model. It's not. It's just not. I mean, it's a different model. That's why we call it the particle model. I don't know. We'll call it the Hilster model. And when it dies and no one cares about it and it never is adopted, then it dies with it's the whatever name it is, right?
Well, let's get back to, let's suppose we'll go back to taking the original picture there and possible reasons why that could still exist even in the vastness of space, right?
Right.
So suppose the ether particles were made out of ordinary matter. How would that change things?
I don't think it, what's ordinary matter? I mean, we're getting to the
Ordinary
question.
matter has one property, which it is gravitationally attractive.
Okay. Yeah, this can't happen. In space, this can't happen.
And why is that?
Because there's no reason. Once a particle hits another particle, it goes off into a direction infinitely without end.
Until it hits another
Until
particle,
it hits another one.
which then it goes another direction.
Right. But it's not going to if you have random particles and going in random directions, you're not going to get a wave that's going to propagate through that in this form, because we know that we have waves of light coming from a star and we can see it and it's coming from that direction. It's not random, because otherwise what you'd have would be light in all directions and it would be right.
It demonstrates that air is just such a medium where the particles are going everywhere.
Well, no, they're not. If you watch them, they will move around in a Brownian motion, but they're not going to go 4 miles from you.
No,
it's in a local area.
The next particle next to them. So
but I mean, in general, that particle will be, and particles near it will be making these waves go, and it's not going to be moving it. Yes, and we also know that in air, when wind is blowing, that it affects sound waves greatly, right? That if you have a wind blowing and you shout against the wind, people aren't going to hear it as far on the other side. So yeah, I mean, yeah, if they're moving and they're flowing, but again, these flows are caused by what we call polarity. That is polarity between atoms, right, or molecules. That when they get close to it, there is attraction there that's beyond gravitational. That is polarity. If you believe in Lionel Denis, then that would be magnetic, or the Coulomb's law, whatever you want to call it. But that keeps it in a general local area. Yes, it's not going to stay.
We just got the question about why we're talking about specific ether theories, and I think to a certain extent you have to, because otherwise you don't know what you're talking about.
Exactly. You have to understand what a person's talking about. You have to understand what David de Hilster is talking about. And what I'm trying to do is, if I take 1,000 scientists and say what would be luminous or ether and light being a medium through it, they would look at this diagram that I have here and say, yep, that's it. So I'm trying to use the standard definition of ether. I'm not coming up with some fancy particle that has new properties that do new things. I don't have that. So yeah, I am saying I'm trying to take standard ether and make come up. I've been trying for decades to come up. Can I come up with something? Because I don't think Aether is a good model myself. Doesn't mean it's right. That's my opinion. That could I come up with something that I would consider to be almost fatal? So
Yeah, well, as a etherist, I'm trying to see whether I can help you determine whether that really is a fatal thing. Now, the what I would have to do in order to do that would be to give you some reasoning or logic to suggest that probably the easiest one would be to suggest that there is some inherent attractive force for these ether particles so that they don't actually.
No, I mean, that would be a logical, that's the logical conclusion. I would agree with you. I mean, you're spot on that, on Franklin. If you want to stick to an ether being a medium where you have light and waves, you're going to have to come up with some kind of mechanism where these things don't go flying off forever in directions and you end up with just a gravitic field.
Okay,
basically,
so I have a quiz for you, David. So it's a simple quiz. And do you remember what my model of the ether is?
You have a proton and electron together that forms an ether particle, I believe.
Okay, very good. So let's say, we have, it's fundamentally made of electrons and positrons, which are
positrons,
particles, right?
Fine. Mm-hmm.
Right. So
with the magical properties of charge. Yes, I got it.
Magical properties of charge. But, assuming we have these things, right, then what would happen if you brought another one of these things next to it? Now, they're charged objects, so what do you think they would do? Would they repel each other?
Well, the question is why are they traveling and why are they coming together? If they are, you have to figure out in space, what are they doing? Space, they're not sitting in space. They're not sitting around next to each other, jawing and having conversations. They're going to be going in a direction for some reason, launched for some reason.
Let's just take every particle in the universe away, and we just put these two things next to each other. And what do you think is going to happen?
Well, that to me is not a realistic. I don't know.
Will they stay exactly in the same positions that they are?
No, I believe if you have nothing else in this fictitious universe, that they would, there would be no forces to keep them even together, and that whole thing would just poof away.
You think they just poof away?
No, not move. I don't think you can I don't believe in experiments where you can get rid of everything in the universe. I'm Borkian, that everything has to be held together by, no, I know, but I can't, I think they're I don't think they're legitimate experiments.
Two particles here.
I don't think that they're a legitimate experiment to have only two particles in the universe.
Okay, there are a million particles in the universe, but we just happen to have these two right here.
Right.
Now, what do you see here? Now, the red is attracted to the black. So
I would say if you have an explanation for charge, then I would believe that. Right now, it's a magical force.
It is, but we know what it does.
Well, you know what you say it does. Right,
how something works in order to predict what it will do.
Sure, I understand that.
We have the red and we have the black block there. What force will develop between the two?
I don't know. Again, I don't know what you can tell me what you would say. I would say until you give me a reason what those forces are, I can't agree.
The positive and the negative charge?
None. I don't believe in charge.
There's the Coulomb force.
Okay, so you're going to call it. Okay, now you're saying Coulomb force. Okay, now you're saying Coulomb force. Okay, now I'm listening.
The Coulomb force. So what does the Coulomb force say the black block is going to do to the red block?
We'll come together.
Coulomb. They will come together. Excellent. See, that's all I wanted you to say. Is that if you have two of these kind of particles, that there is going to be a tendency for them to actually attract each other. They could attach this way. They could attach this way. They could attach.
Understood.
So I'm just trying to motivate for you.
Because, I guess my question is
not about this particular objection, but you are correct in that there has to be some kind of attractive force between the ether particles to keep them close enough so that they just don't fly away, right? So that would kind of be
Yeah, no, I think that's a legitimate
possible way of that working, right? It's just
First of all, I want to congratulate you on two things. One, you're listening to the objection and understanding it. Two, you're going to try to make a solution to it instead of telling me how Ether works and how this doesn't matter. That's
yeah, I mean, it
not
matters.
normal. Yeah, I know, but that's not normal from what most etherists would say. I mean, are you totally fine with the idea that Ether could not be the model for what we think light is?
It could be there. I mean, there's I mean, we have, you know, it's either it's something in a medium or it's an individual particle flying from point A to point B, right? That's I think.
Or it's a lattice.
Well, I would still consider a lattice a compression rarefication.
Sure, I understood. Yeah, you can if you want to talk about it that way. Yeah,
versus it being, say, a particle that has to physically travel from point A to point B, right? I mean, this is the thing about, say, the whole thing about whether light is a particle or a wave, because it genuinely appears to travel like a bullet, right? So like you say, your laser thing, it's not like a speaker where, you know, it spreads through the whole room. It's more like a gun where you shoot it from one side of the room and it goes and hits the other side of the wall like a bullet. So that's very particle-like, right? Now, so the thing is, as an etherist, yes, I have to explain that, right? Although as an etherist, I don't have any, you know, quote unquote proof, right? All I can do.
Well, nobody has proof for that.
All I can do is motivate, you know, the nature of light, and the nature of light generation itself is that, you know, there's some electrons bouncing around somewhere, and at some point it drops from one level to another level, and that releases what we call a photon, right? And the thing about these photons is that they are a wave. You know, I think I had a talk about this where I discussed that light travels like a pencil. That if you were to look at what the shape of the actual light wave is, that you would see that it has a finite length, it has a finite width, and it travels as a packet. It's a wave packet. I think in physics they call it maybe a soliton. Perhaps it's as much. It's like you took a rope and you just jerked it once. It's just like one.
So you're now discussing your ether model, right?
Yeah. Well, I'm trying to motivate. Why is it that you know the light say well, this is your objection. You know, how does the laser travel thing?
Right.
Which
right.
is that the thing is that if the ether is this, you know, jam-packed, you know, bunch of positive, negative charges like that, I would say that acts a lot like a Newton's cradle, where you put the energy through one side, it goes through the other particles, and then just immediately shoots the other one out. That you see that is a wave, but it's traveling exactly like a particle in that it's going in a straight line. It's not dispersing.
I'm curious. Can you describe my father's model for light?
Well, it isn't your model that that you have particles being emitted in groups, and that you get the what we detect, I say, the wavefront as the impinging of those sets of particles. Is that
yes? Yeah, very correct. Yes,
I think you know I've heard of that. You know, other people.
I've never heard it anybody else. If you can find them, let me know, because I've heard people claim to say that they knew. One person said Rodin said something about that. There's the guy who swears every other word, who's the that I know interact with, who
that guy.
But it's a different model. It's a different model. No, it's a different model. He says it's the same. It's not. And he said that only after we talked about what we had. So no, that's not true either. But regardless. It's most important that you understand what that kind of model is. Okay, because to me, I think the thing that came up that was so amazing about my father's model, it's not mine, of light, was that it addressed one thing we all forgot about with light. It's got a frequency. In frequency requires more than one. That's all his model is about. Frequency requires more than one thing. You can't have a frequency occur with one thing coming. You can't have, the frequency of flights in this airport is this one airplane that arrived on January 7th, 1947, and there was never a plane. You can't give a frequency to one thing. You have to have more than one thing for a frequency. And I think that's what was so, I would describe, my father's his solution to what light is. But I think, first of all,
discussion about what frequency is, and it's like
frequency is a something over time, something over time,
and the frequency at which you throw the rocks at the wall determine the frequency. Is what. So, although one of the consequences that means that the frequency you get, it's a bang, right? It doesn't really have a shape, right? If you were to put it on an oscilloscope, it would look like, I don't know, like a square wave, or, But so I did an experiment to try and determine, is frequency like coming out of radio transmitter? Is that really just pulses, right? And that the pulses are all the same. And that, right? Would you agree? I mean, if radio.
Well, I mean, we're writing my dad's writing a book on what we consider to be a physical model for electronic circuits, light, gravity, the magnetism, the whole thing. So yeah, we have a pretty detailed description of what we think's going on. But again, it's just our model. So, okay. Well, anyway.
I just said this is an interesting experiment that I did. So, I made the prediction that if that were true, then if I have my radio transmitter, then I should be able to put in any input signal, square wave, sine wave, triangle wave, shouldn't matter, because if the radio receiver is over there and only receiving the hits from the throwing of the rocks, then it shouldn't matter. It should be received exactly the same way. Although my experiments show that it's not, that if I transmitted a triangle wave or a sine wave or a square wave, that those waves are actually received that way at the receiver. So now I know there's other ways of kind of finagling that so that still works, but you just can't consider it just like throwing rocks against the wall, that every pulse.
Well, in our model, that's not the way it works, because you can have groups. The groups can have more in a group, so you get basically sine waves. You can get almost any kind of wave. You can get any kind of wave with that model. My dad has actually described how he came to that kind of solution in his head. I think part of it had to do with him working with the digital world of electronics, which sends things in digital format, and that kind of got him to get to that kind of model. Okay, well, listen.
I'm just kind of curious as whether I've been able to move your
No. What? First of all, the whole thing is a couple of things that I do agree that rarefication and compression that you could sort of call that I'm talking about. The difference would be a lattice model's doing that with fixed particles or a fixed mass, whereas the ether, luminiferous ether, does that where they're more free, like a gas. That I agree with. And I also congratulate you on understanding the objection and actually trying to come up in your model with a solution as to why you could have ether and this would not be a problem. So that's very, very good. Congratulations. Hats off.
All right. Very good.
All right. Okay. Thank you so much. Whoops. I got to learn how to do all these things. We have James Keene. Are you there? You'd like to come on and make some comments or something? Yeah, I do want to see here, Richard Jess, the problem with a material ether is, does it have a location? Is it moving? If not, if so, where, with respect to what? Yeah, these are very good questions. I agree. Before I get to you, James, I just wanted to bring this up. So Richard Jess, I agree with you. I have the same notion. If you do have ether, even as Franklin would say, which would be help solve this, that somehow it would sort of stay together. It's staying together in reference to what? Is it all moving with us? Are there other things? It's a darn good question. And I'm not saying I have any answers or objections or whatever to it. But if you do have an ether, you do have that. Whereas again, if you have models that are just traveling particles that flow in directions, yes, they do collide, but they don't really form some type of medium. You don't have that, how do you say, local framework problem. And I think ether will have that, and it's inherent. So I think that's a good observation. All right. Yes, James. Hey, James, how are you?
I'm fine. Hello. I just have a brief question, which may be a little bit, or suggestion,
Sure.
which may be a little bit off topic, although you did mention your father's experiments with the resistors.
Right.
And I watched those sessions recently in this forum. My suggestion or query is I would like to see a statistical analysis of how your data or his data is different, significantly different from the voltage divider model, for example. In the standard model is you get certain like you've got two resistors in with the current going through, and you can measure between them, and the voltage divider model. What I didn't see in those presentations was what that model would predict and what the data is that you got, and is it statistically different than what the standard model there of
I guess
would be.
No, very good question. And I just want to get a quick clarification from you. When
Yes,
you're
sir.
talking about model, it's more of empirical equations that are used in electronics.
Exactly. Yes.
Okay.
Yes.
Okay.
That
Because what the
electrical
difference
engineers, like, for example, if I got 12 volts running through two 1K resistors in series, and they're both exactly 1K, I should get at the middle point between the resistors the voltage division of 6 volts. So your father made
the different, I think, yes, right. And I think the only thing I can say, and don't quote me
Uh-huh.
on this, because this question really needs to go to him, because this is his expertise,
Right,
even in
yeah.
our model. But from
Understood.
what I do know is that current is expected to be the same around the entire circuit, and our model shows it's not. It's different, not by much. In fact, we had to buy a voltmeter that went to 7 digits, 0.000001, to be able to see it. But there are some things that are considered to be constant or the same in places in the circuit, and we turn out when we measure them they aren't, and that's part of it. That's all I can say. That's and my
Okay.
feeble understanding. But what you should do is send that question to my father, and he would be happy to answer that.
Yeah,
It's a really good question.
that would be supplemental to the data you already present,
Right. Of
or that
course.
he already presents. So that the traditional guy like me that uses this voltage division equation,
Right.
I get this answer, but your data is that answer, and they're
Yeah, but I will say that
significant. That's what I'd like
right.
to see.
The two things, no, they're not significant
That's all.
normally. Yeah, they're not significant normally, right? They're pretty small, the differences. The other thing too is we can give a physicality, a physical reason for the transitional states of transistors, of resistors, of capacitors, and we can give a physical explanation for those. That's sort of our goal. And that is, what would be a possible physical explanation instead of holes and electrons moving at meters a second and holes moving in contrary direction. So, but no, you're right. And again, I would say that they're not, how do you say, significant differences. They're small differences, but they could be significant as we get
The
smaller and
size,
we don't
the
know.
absolute size of the difference is not the key question. Are they statistically significantly different? Like how many standard deviations?
Right, right,
If
right.
if
If my father's
your
having,
model is predicting something different than the standard voltage division equation,
Yes.
you have to demonstrate that to people like,
Right, we have
Dummy.
it in the book. We
That-
have it in the book, and they're demonstrated, and the numbers are there. So yeah.
Okay,
So
thank you.
what will happen is you can talk with my dad, and he will be much better to answer those questions than me. So
Okay, thank you,
but
sir.
very good questions, also. Thank you.
Thank you.
Okay, and about Ether, did you have any comments about Ether and the idea of containment or not, or was that just not something that was?
Well, some of the listeners here may know that I don't believe in continuous space or even continuous time.
Okay.
So all of the discussion is based upon the assumption of what I call the mother theory, is that space is continuous. And so, in other words, I'm in a different ballpark.
Mhm.
I believe that space is not continuous.
Got
That
you.
it has a discrete structure, which
Sure.
is a whole different avenue. And
Sure.
so I'm neutral on the comments that were made
Got you.
today because it's
No,
based
I
on
understand.
the assumption of continuous space.
Right. I understand. So, I mean, it is, I got you. So you have a different type of concept and model for really what's going on all of this. So it's not something interesting to you. And yeah, I mean, I'm not an etherist, so I'm not too worried about it. I was just trying to figure out why I didn't like that as a model. Was there something I could find that could finally squash it so I don't myself think about it? But that's totally, I understood. In fact, I've got a book back here from a Canadian guy who talked about time and not being discrete. And he got that from
Not being discrete or
yes,
being discrete.
not being discrete, right here.
Not being continuous, in other words. Okay. Well,
And
the title suggests discontinuity.
Yes. So anyways, I'm lucky enough in that sense to have people who know that I love to look at different ideas, that they'll send me their stuff. So I'm very privileged with that. I'm very happy to
Well,
get
thank you
those and
for
read them.
today's presentation. I enjoyed it a lot.
Oh, well, thank you very much. Thank you. I know Taiwan Cricket is in you can come on and talk, or you can, let's see if we can put some things out. How can expand when magnetism holds the dielectric component? Let's see. I'm just trying to see if I can see some comments here. Oh, I got to get you down there. I'm sorry. What are we doing on time here? Because we got 15 minutes left. May differ between the velocity, acceleration, and so on. So time is similar to an angle swept out of a trajectory, not a dimension. Yeah, time is not a dimension. That just doesn't make sense. We talked about time. Who talked about time was Nick Percival. If you haven't seen those folks, you should take a look at his 3 lecture series we had here. Absolutely fascinating. If you loved the idea about thinking about time and stuff, go back and look at and watch those videos. Nick Percival on time just will get you really thinking. Oh, I do see Taiwan Cricket is there. Did you want to come on? Wave to me there. Would you like to come on and make some comments and whatever? Yes, okay, let's bring him on. Hello. Oops, I don't hear you. It seems like we got to get you. Do we hear you
Is
now?
that better?
Yes, very good. Hello, how are you? I really appreciate you coming on. The floor is yours. You can say what you would like to say. Like,
Sure thing. I made a private chat comment there. It says,
yeah, I can't get
just
those.
open.
Unfortunately, the only way I can get this stupid thing. It's one of the things I requested that StreamYard do. Can you please make it so we can put private, if people in the private chat want to have that displayed for everybody? I can do that if you want me to do it. What was your comment? Would you like me to put that out for people to see, or?
I'll just read it. I'm not sure if it's
Is it gravity is what we're looking for?
yeah, that one.
Okay,
So-
I'll go ahead and post that in all, but you can read it still. I'll
Yeah,
put it there.
okay. So I just said gravity is what they're looking for, like talking about people who talking about ether. So I think they shouldn't be looking for the ether. They should be looking for gravity. Sort of, we can't really explain that. So
Yeah, and I think it's interesting because I know a number of people, Nick Percival, for instance, who doesn't really think necessarily about ether or gravity. He's come to, when he's looking at frames of reference, it seems like one of the problems we have with frames of reference is this whole thing about ether, right? If you have this ether that kind of stays around, what's it staying around in reference to? It seems like the universe would be just more, things move and they just go. And so the gravitational field seems to be more of that kind of nature. It's just, it's everywhere and particles moving everywhere, and you don't have this problem of what is the how do you say, reference frame. People who have studied gravity, studied things that need like GPS or even time, and looking at that, and relativity, Michael Moore and all the Michael and Mickelson and
Moore.
Michaels, whatever, Eminem.
Yeah.
They and Ron Hatch, who was a GPS guy who passed on not too long ago, all those people had said to me, and I'm not saying this is right or wrong, but it's interesting. They have come to me and said they think gravity is the basic, how do you say, organizer of the universe. And if you look at my father and I's model, magnetism, all that stuff, gravity is the basic organizer. Random particles in random directions will cause shadows, which bring things together, cause them to orbit, and all these things the universe is made of. But that seems to be, is that kind of what you're saying? That gravity seems to be the fundamental force from, or what?
Yeah, I would say so. I think, just from a philosophical point of view, if you're trying to analyze the universe and you come up with an idea,
right,
and it's not a physical thing you can touch, but a physical thing you can study, then you have to ground that in something observable, right? So if we talk about an ether, we have to talk about something we can actually measure and we can actually refer to in some sense. Like gravity, I think, fits all the bills. Like, you can't see it or touch it or anything, but you can see its effects. You can predict stuff based on that theory and the calculations with it. So I just thought, yeah, why not? I did some work with Stephen Bryant. And,
right. Oh yeah, of course.
So
he's a really great
thinker.
So
I kind of subscribe to his theory on relativity and all that.
Right.
And the other question I had was, when the relativity people talk about time space, is that just another form of an ether?
No, no. According to them, they're going to say no, absolutely. In fact, space-time is replacing the idea that there would be ether or anything like that. But the problem with the thing with space-time, there's things called foam. Some space-time foam. There is different types of gravity that they have. I can't remember what it's called. It's just pretty crazy stuff. But they pretty much say that there's a photon. The problem with the photon, they can't describe the wave part of it. That's when they get into the spookiness and the weirdness of quantum mechanics and all that, the double slit. And they get into things about even history erasing stuff, that if you look at a photon and I look at a photon, it would go around the planet in a different direction. It's the consciousness. What they do is, because they're stuck on a photonic model and they see the wave and particle aspects of it, they are stuck with this magical world which they have no idea, and it sounds bizarre. And so they're now trying to reconcile gravity and light and the forces in the atom with gravity, which they call general relativity. They're pretty much lost. As to, if you really talk and sit them down about what light is, they're going to say it's a photon, but they have no explanation as the physicality of how a photon can be all the different color. There's nothing. They're no better off than Newton, who was saying in the beginning that photons that were blue were bigger than photons that were red. Basically that. So, yeah, they're lost.
Is it fair to like? Is it fair to like? Would it be fair from our perspective or my perspective to say that like it just seems to map onto like the ether theory, the ether theories, and the time, because like time space seems to fulfill all the same thing.
I don't think so. No, I think if I were to interpret it, and again, just trying to unravel what I call their Gordian knot, which isn't very easy, is that their space time is way linked to gravity and not light, and light seems to be sort of pushed aside. I mean, they're doing gravitational waves, right, with LIGO, claiming to find those, even though two Denmark physicists did analysis and said it was just noise. Instead of those people, instead of accepting that, they literally spent 2 years sending people over to the two physicists to indoctrinate them into what they should be seeing. So these people, the mainstream has really abandoned light a lot. They have really abandoned it. The photon is the closest they've gotten to it. They will say that it's a photon's emitted. They talk about it at the subatomic level, right? With a photoelectric effect, and they pretty much stuck with that. But if you get into the photon, they're going to be getting into the weirdness of the universe, and the universe isn't Newtonian. That's what they'll say. The universe isn't Newtonian. It's weird. It can't be all Newtonian. Here's why. It's because they've never addressed light and frequency and color and any of that. So they have empirical equations to explain things, but they don't have a physicality to explain it. It's still a photon, and the photon fails miserably in the wave area. So.
Cool. That's about all I have. Thanks for your time, man.
All right. Well, thank you very much. I really appreciate it. Anybody else, of course, can always come in the green room. We're coming up to 5 minutes till, but we got all kinds of people saying things about their models, and nothing emits light. Well, whatever that means. Again, you have to have your models. Again, today was just to try to come up with a new idea that for ether that either has to be explained or it makes it not a good model. I think I thought it was an interesting thing. I've never seen that explanation. I think it's a valid one. I think Franklin's on the right path to be able to, if you're an etherist, you better be able to explain why those things are around and stay around, and why would that would be. So it says, since you are knowledgeable about different ether theories, what do you think about the Stephen Rado ether theory? Well, I did read about it. I'm not up to date on it. I would be, if you I could read about it for sure, or somebody could present it. That's the best thing. So Super Principia Mathematica, I know you are not a fan of mine at all, but doesn't bother me. I have no emotional attachment to that. That's totally fine. But if you want to, present the Stephen Rado theory, that model, that would be fine. I know Stephen Rado. I've read some of his work, but my little brain can only hold so much. I don't remember it per se. Especially since my father and I've been working on a different model for a bunch of years. My brain can only hold so much. So, but love to hear from anybody who has their ether model, wants to explain things. Anybody's model, it's welcome. This is what this group is. I'm not here to tell you can't. I don't believe in ether, so don't even try to explain it to me. Nope. I'm always interested in learning about how models work and people's ideas. So. All right. We're going to take this out as we normally do. And I want to thank everybody who came by today. And I hope you understand that I'm not here to say that ether models are wrong. I myself don't like the model, was wanting to come up with a major objection that I thought, and I came up with a new one. Is it a major objection? This is, I came up with a couple of weeks ago after decades of trying to find something, and I think it's interesting. So I hope you've enjoyed that stimulating thought. And again, if you want to help us out, please hit the like button, hit the subscribe button. We want to get at least 1,000 on the CMPS YouTube channel. and Dissident Science. I want to thank all my listeners and all my subscribers for subscribing. We hope you enjoy this. I know Tao Lin and it will be doing some of his mandala drawings and listen to this. I want to shout out to you. I want to thank him for coming on. And again, if you have anybody who you think should be on that would be interesting to talk about, or if you want to come on and be one of the hosts here, you like this kind of stuff and like to talk about it and think you can do what I'm doing much better, which isn't that hard, folks. I never claimed to be good at this. So I do have at least empathy and respect to everybody who does things that I do have. I respect every person here who's trying to fight for some new ideas. If you have your own model and sticking to your guns, I will support you to the end much more than I support universities who try to tell us there's only one answer, because there isn't only one answer. And so thank you so much, everybody, for this. And let's get ourselves out of here with some of what we're all about here. Hey, I'm David de Hilster. Remember, I say, stay critical, stay thinking. I'm your science therapist trying to get you to the promised land to become a critical thinker, open up your minds, realize that everything we're told about science doesn't have to be true, and a lot of it isn't true, and that there are great people, great minds outside of mainstream moving science forward. That's the way it always has been, and that's what this show is about. Ciao for now.